Thank you so much. Yeah, they have
I
a
lost
they have a
I lost the first tape.
say it again.
I lost the first tape of this problem.
Oh, you got lost?
I lost the first tape. Why? What you do to have the G?
D?
Yep.
Okay. The way we got D, you write the coefficients. You gotta have everything in order. X's over X's, Y's over Y's. And then you just write the coefficients down as they appear. So what we wrote a 5, 3, minus 2, and then we have minus 2, 3, 5, and then minus 4, 2, 3. And then I just expand it. I expand the first two columns. So I go 5, 3, minus 2, and minus 2, 3, 5. And then what we did, I won't redo it, but what we did, we multiplied the diagonals, right? Like that. Got our numbers, and we took the difference between the diagonals from the upper left to the lower right, minus diagonal from the upper right to the lower left. Now, I don't know if you did we did a 2x2 determinant of matrix a couple videos ago, and I don't know if that was the one I forgot. I didn't put it up yet, so I'll put that up. If you didn't see this, if you missed the last lecture, I'll put it up on. I don't think did we do that on video, or did we do it? I can't remember where we did this. If I was at the school or if I was here in the basement.
It was on video.
It was on video. Okay, so
Yeah.
if you missed that video, I'll put that up so you can see how to do this. I don't think I put that up, but I'll do it after I'm done here. So,
Okay. Thank you.
but I'll do that. If you have any issues, just send me a text, and I'll be on my computer for a while. Oh, hey guys, before we go on, I got a paper with no name on it. I don't know if you can see this or not. Let me try to hold it up to the camera. Somebody identify this. Can you see that or not? Can
you bring it closer?
Was the camera focusing on it?
Not really.
Yeah, it's lab 4.
Yeah, I want to know whose it is though, because there's no name on it. So somebody did a nice job coloring. Here's the second page. I don't know if you can send it. I know what it is, but I don't know who to give the grade to. So I don't know if you can see that. Check Blackboard. If you got a 0 for lab 4, this might be yours. I don't know if you can see it. I can't see what the camera's focusing on, so I'm going to try to bring it close.
What's the grade?
What do you want to know the grade for? You want to know if it's 100, you'll take it, huh?
Yup.
Okay. Well, if you look on, I think I got most of the grades in. I might be missing a few, but if you got a 0 on lab 4, let me know, and I'll maybe I'll have my nephew take a picture of it and send it out and see whose this is. I just don't want to give you a 0, and I got some other ones with no names on it. I just don't have them here. So, all right, did we get this product? 27 minus 12 and a 60. Give me that number.
75.
Okay, we got 75 minus, and then we got to go the other way. So I try to make use of the coloring pencils and pens. It just makes this a little easier. So I go this way. I got a 9. I got an 18. I got a 30. I got a 12 times 3 is a minus 36. Now make sure I'm doing my math right, because I'm just doing this off cuff. I got a minus 36, I got a 30, and I got an 18. How much is that?
12.
I got 12. The positive 12?
Yeah.
12. I want to divide that by minus 63. And I can see on top that's a 63, so that gives us x equals a negative 1. So we got a negative 1 for x. So I don't want to work the whole thing. I think we'll do one more. We got x at negative 1. Of course, when you get the first two, you can just substitute and get z if you wanted to. But let's do one more. Let's solve for y. You go ahead and you solve for y, and we'll compare answers. And if we get it and we think we understand it, I'll jump right into the problem I want to apply this to. So go ahead and set the determinant up to solve for y the way you think it should be. So I bought a scanner. I bought a copier, scanner, fax machine, so I'll be able to get some stuff up for you guys. So some kind of way I'll get the exam ready by, I said Wednesday, I think. Steve had asked about that. And then I decided what I want to do so that we're all on the same page. Some of you already have a link. I don't know what you call it, the copy of the PDF form of the book. I think it's edition 9 or something like that. I'm going to send everybody the link, and we'll just work out of that. That way I can assign homework, and we're all doing the same problem. I think we have about 3 different versions of the book out there. So I'll send the link out, and from here to the end of the semester, we'll just use the link that I sent. We'll use the PDF version of the book, so we all have the same homework problems. It'll just be easier for me and easier for you. So you're setting the determinant up to solve for y. Shit. And that's going to look like this. Actually, I want to solve for y, so I don't want to write this. I'll take this and put it in the place of the coefficients for y. So what I just wrote is not correct. I got to put this 3 minus 3 and 3, and then a minus 4, 2, and 3. And this is for y. I take that over minus 63. Expand the columns. And then do your math. Okay, so I got, let's see, 15 times 3 is negative 45. I got 6 times 2 is a negative 12. And 12 times 3 is a minus 36. So if I did my math right, I got a negative 45. I got a minus 12, a minus 36. Add that up and tell me what you get. Make sure I did it right.
93.
How much is it?
Negative 93.
Negative 93 minus, and then let me move that somewhere else. I'm going to move it up top. I know my board is getting crazy here. Somebody said we got a negative 93, and I put the minus sign down right away so I don't forget it. And then I'll go the other way. That's purple. I don't want to use the same color. Let's try the blue. Okay, so I got 9 times 3 is 27. I got 10, I got 30. And I got 12, 24 with a negative sign in front of it. When I did the multiplication right, I got a negative 24 I got a 30 and I got a 27. How much is that?
Negative 81.
Negative 81 divided by negative 63. And let me know what you get.
2.76.
Okay, that is not correct. Because I did it earlier and I got a 2. So if something's not right, if you got 2.76. Anybody second these numbers? Let's see if we can figure out. That looks all right. That looks all right. That looks all right. And then I got 15 times negative 45. That's all right. That's a 6. Minus 12 is right. Negative 36 is right. Add these up. Say it again.
It should be negative 93 minus 27.
Oh, up here.
Yeah,
That should be negative 93 minus 27.
yeah. And then when you divide that by negative 63, you get 2.
So this should be negative 93 minus what?
27
27.
or 23. Hold on.
Did this give us a negative 93?
Or 33. Hold on.
Yeah, I got 33. This should be 33.
Yeah, sorry, 33.
But what? Well, all right. So 33. So does that add up to 33? Negative 24, 30, or 27. Does that add up to 33?
33, yeah.
Okay. All right. So we're good to go. So then you do the math and you divide and you do get the 2. You get 2. So Z, you can do the same way. I'll just give you the answer. I worked it right before class, and when I worked it, I ended up with 179 over minus 63. I ended up with negative 3. So you can work that yourself and make sure you get the negative 3. But I think you can see how to do this. It's not too bad. Now, you may think this is a lot of work, but if you ever had to solve one of these, like a substitution, you can do it. I've done it before, but it ain't pretty. So this is a much better way to do it if you have more than 2 unknowns. Actually, you do it kind of quickly when you get the hang of it. It goes kind of fast. Just got to do your arithmetic right. But you guys got calculators, so now your calculator will do this. If you have a TI, the program it'll do this automatically. You can just put in the coefficients and hit solve. It'll do it. But I didn't want you to do that. I want you to see what the calculator is doing. At that point, if you want to do it using your calculator by just hitting the solve button, you can do that. I don't care. But I want you to know what the calculator is doing, or one way the calculator could do it by actually working it out for you by hand. So with that said, let's jump into the actual circuit. How do you use this stuff on the circuit? And so last time we talked, we solved the circuit using 2 methods. We used superposition and we used the method of mesh analysis. Superposition, I like superposition because it's very intuitive. You can actually see the direction of currents for each individual source. It's very, very intuitive, but the problem with superposition is you got to draw a bunch of pictures. Mesh analysis, you can draw one picture and let the math do the work, but the problem with it is it's like magic. I mean, there's really no such thing as a loop current. We make up this thing called a loop current. The math does the work, but then we kind of lose really what's going on in the circuit. It's like magic. So it's not very intuitive at all, but it's much more direct to get an answer. And I'm going to show you one more way. We probably won't have time to do it today, but I'll show it to you next time, and then we'll move on to something new. So this is going to allow us to solve, basically with mesh analysis, for every window you have an equation. For not every loop, but every window. If I have 4 windows, I'd have 4 equations. 5 windows, I have 5 equations. When you get that many windows, it's better to let a computer solve the circuit for you. But we'll do a 3-window mesh, and I don't want to go above a 3-window mesh. I think that's plenty enough as an example to see how this stuff works. So let me go ahead and put the circuit up there. You get pen and paper, and we'll start to solve this thing together.
Hey, Ron,
Uh-huh.
got a question for you. One of the guys is having trouble getting into the class via phone because the pin is apparently not working. Can you see if the pin that you sent out in the announcement is correct?
Yeah, let me see. Now, hopefully you guys don't get disconnected. Hold on a second. Let me see if I can do that. Okay, I'm gonna have to get out of this for a minute, but just give me a second. If it disconnects, I'll be right back. I wanna get out of here. Four two eight. 428 60. $35.94. All right, here's what I'm seeing for the pen. Are you talking to that person now? Who is that? Sam? Who is that?
It's Ethan, but Matthew Felix is the one having trouble. He said that pin right there is not working.
Okay, that's the one I'm looking at the computer right now. And he has to, let me just double check. 428. And make sure you got the right number. I got 1571. 571. That might be in the reflection. Let me put it lower. I got 571 392 392 7650. So make sure this is the number he's calling with that other pen. That's what I'm seeing on my blackboard. So if he still can't get in with that number and that pen, he might have some other kind of issue. Are you talking to him?
He's been in chat, but he just can't hear anything.
Oh, he can't hear anything?
Yeah, that's the issue.
Oh.
You should be able to use your phone just as a computer and use the link in Safari or whatever web browser you have and still be able to access audio and video from there.
It should be, but
Yeah, he was having some other kind of issue. Do you know if that's the number he's calling?
As far as I know, he got it from the same. I'm assuming he got it from the same announcement as that.
He should have, yeah. And I'm looking at the screen now, so that's what I'm seeing. I guess what you're gonna have to do is I'll put this up on the YouTube. Unfortunately, he won't be able to ask any questions, but he'll be able to listen to the recording on YouTube. I'll put it up right away. I was supposed to work with somebody on some homework though after this. I hope it wasn't him. I can't remember who it was. I think it might have been him. So we're gonna have to figure out a way to connect with him. Well, okay, I'm gonna go ahead and finish because I don't want to run out of time. And then I think I have his number. I'll give him a call. But if you're communicating with him, I'm going to finish and I'll have to call him on the phone when we're done. Because I think I was supposed to work some homework through the video or with him. I was talking with somebody last night. I'm pretty sure it was him. Let's go through the steps of this, and then I'll call Matthew when we're done. I don't have a lot of room, so you guys are going to have to do all the calculating. Okay, so I have a 3-window mesh. The value here is 3 ohms, and this is 4. You got a 1, a 1, a 2, a 3. All right, I got all the values. So you got to write down the polarity of your voltage sources. That's determined by the symbol, so that's easy to do. And then you're going to assign what we call loop currents. And what we said was we're going to make all of our loop currents go clockwise so that we all get the same equations. So I'm going to call this one IA, IB, and IC. And I'm going to put in my loop current like this. So there are my 3 loop currents. Now what I want you to do, go ahead and put the polarity for each resistor up here as defined by the direction of the loop current in that resistor. So go ahead and do that, and then we will get the equations. I don't know where I'm going to put them, but I guess I'll find a place. We'll get the equations, and then we'll set the determinants up and see if we can solve it. So write the polarity would be the next step. And if you remember, if I have a resistor, current is this way, polarity is like that, current is that way, polarity is like that. So in this resistor, current's moving up, positive, negative. Over here is moving down, right? Positive, negative. Remember I said before that the sign of this has nothing to do with the sign of that battery. If you thought like that, you would put a negative sign here because it's against the negative sign of the battery. It has nothing to do with that. It's all about the direction of current through the resistor. Since current is flowing this way, you assign that part of the resistor positive and this part negative. And on the other side, remember when you have 2 loop currents, you treat each window independently. So over here, if IA were the only loop current through this resistor, it would be plus minus. And on this side, in this middle window, I ignore IA and I write plus minus for IB. And I do the same thing for this one, plus minus, and then for this one, plus minus, and then plus minus. So make sure your polarities agree with what I have here. And if they do, or what I want you to do is to see if you can remember how to write the first loop equation. So write the first loop equation for window 1. I'm not going to have room here. You guys are going to have to do the determinant. I'll set it up, but you'll have to work it out because I just don't have any room down here. So let's get the first loop equation up there. I want to see if this blue shows up. I don't know if it shows up on the camera or not. I'm going to start right here. I usually start in the lower left. You can start anywhere you want. If I start here and go around following IA, I hit a positive or a negative to a positive as a rise, so I write that 2 as a positive. If they've been flipped over, if I went from a plus to a minus, I would write it as a negative. So I go from a minus to a plus, I write that as a positive 2. And then this is a drop, so it's going to be a drop, so it's going to be a minus 1 times IA is a minus IA. And then right here, I go from a plus to a minus, it's a minus 4. And then right here, I got that case where I have a resistor that has 2 currents in it. So I have 1 current going down, 1 current going up. That means I'm subtracting. It's a subtraction of currents. So I'm going to write, I can either write IA minus IB, or I can write IB minus IA. And what we said the other day is, whichever window we're in, we're going to write that term first. So I'm in the IA window, so I'm going to write IA first. When I get over here, I'll write IB first and use that one. So I'm right here. I got 1 times. It goes from positive to negative, so I have to write that as a minus IA minus IB. And now I'm back to where I started from in that corner, so all that equals 0. Now, I don't know if you can see that because I think it's in the reflection. But I got a 2 minus IA minus 4 minus a quantity IA minus IB equal to 0. And if you do the math and get everything, all the terms, I don't know where my black marker went. Oh, get all the terms together. Let me use a purple so I don't, trying to keep this thing nice and color coded so you guys can see what I'm doing. So I got minus IA there and a minus IA there. So I got a minus 2 IA. I got a minus 1 and a minus IB. So I got a plus IB. And then I got a plus 2 here and a minus 4. Add those together, I get a minus 2. I'm going to move it to the other side, so I'll get a 2. But you got to do something before you do that. Notice I don't have a C here. I don't have because this current never touches this window. So when you're faced with that situation, you have to put a placeholder here, plus 0 IC. You got to put that placeholder in there because you got to have a variable with an A, a B, and a C in it. So I have to add that 0. Remember to add that 0 in there. And all that equals negative 2. I'm sorry I'm running out of room here, but hopefully you guys can see that in the camera. Minus 2 IA plus IB plus 0 IC is negative 2 is what I got. Does that agree with what you got? Is that right? Anybody else get that?
Yes.
Okay, so go ahead and do the equations for the next one, the middle window. I gotta start making I'm gonna move some of this on the inside of there and see if I can make some room while you guys do that. 2 volts. All right. So if we, I think I'm gonna work it down here, and I'll just copy it up here. Or maybe I should write it down there. I wonder if you guys can see that low. Let me see if I can see in the camera.
Yeah, we can see that low.
Okay, I'm gonna put it over here just to clean that up and not to write the determinant up there. So for the first equation, let me get a chair, I'm sorry. So for the first equation, we got all right. So now I can erase this and we'll put the other one up there. Okay, so let's get the equation for the middle window. Now, the middle window, in this resistor, it touches IA and IB. In this resistor, it touches IB and IC. So we don't have to put that placeholder for the middle one. It's gonna already be there. When I get over here, this touches IC and IB, but I have to put a placeholder in there for IA. So eventually you'll have to do this on some kind of exam for me. If I give you a 3-window mesh, just remember you gotta put those placeholders in there. But it looks like everything now is take home, so it's not like you won't have your notes. So you should do all right on it. All right, let's get the other equation for the middle window. Excuse me. All right, I'm gonna start here and go around. Now here I have a situation where I have one resistor, 2 currents. I'm in the IB window, so I'm going to write IB first. I'm going to write IB minus IA. So I go from a plus to a minus. That's a drop. So I got a minus 1 times IB minus IA. And that puts me right here. I go from a minus to a plus, so that's a plus 4. And then I go from a plus to a minus, so it's a minus 2IB. And then over here, I got that thing where I have 2 resistors. I got one resistor with 2 currents in it. So it's a drop, so I got a minus IB minus IC. And I'm back where I started. So all this has to equal 0. So combine your like terms and do all the math stuff that you know how to do. I'll do it, and you just compare it to what I got and make sure I did it the right way. So what I'm seeing here is I got a minus for A. So I got IA. I got a minus IB here. I got 2 more negative IBs there. That's a total of minus 3 IB. And, I think I made a mistake. No. This doesn't look right. This should have been a 3 in front of there, right? When I did this, I went from a plus to a minus. I got a minus, but there's a 3 in front of there, so I should have put a 3 in front of there. Sorry, this should be a 3, a minus 3. It should be a minus 3. I got to pick up that resistor. So let me go back and rethink this. So I got a minus, I got a plus IA. I got minus 2 IB here. And I got minus 3. That's minus 5 IB. Minus 5 IB. And then I got plus 3 IC. And if I move this to the other side, I get a negative 4. Is that right? Anybody doing this with me? I don't feel like I got that number when I worked this earlier, but I might have. Are you guys working it?
How'd you get like how'd you add those up? I can't remember how to add them, like, for like the -4.
Yeah, let me erase this and go back and now here's what I got. So remember what I got. I want to do it again, make sure I did it right. But write it down. Make sure what I'm saying is IA minus 5IB plus 3IC equals -4. So remember that. And let me erase this and go back and redo it. Okay, was that Kevin? I think that
Yeah.
was Kevin asking about. So let me just write it out. I just want to make sure I did it right so I don't give you the wrong information. I'm going to turn my light of this camera around one day so you guys can see, but I got like 50 lights on me, and I got to get a fan in here. I turned my furnace off because there's furnace pipes right here, and I end up burning up down here like burnt toast. There's still not enough light. I can add more lights, and I don't think it'll still would be enough light. So I want to redo this. I'm going to write it a little smaller so I can make it fit here, so I'm hoping you can see it. And then we'll work it out. I'll work it out all the way. I think that was Kevin. So I started right here. I go down from a plus to a minus. That's a minus. That's a minus. I'm in a I have a resistor where I'm sharing two currents. So I'm in the IB window, so I'm going to write IB first. So it's a minus IB minus IA, right? And then I go from a minus to a plus, so that's a +4. And I go from a plus to a minus, so that's a -2 IB. And I'm over here with the same situation. This is where I forgot to write the 3 before. So I go from a plus to a minus, so that's a -3. And since I'm in the IB window, I gotta write IB first. It's gonna be IB minus IC. Then I'm back where I started from, so all that equals 0. So I think that's the same equation I got first. And then Kevin, you were asking about, so I'm gonna, remember I gotta distribute this to get rid of the parentheses. So if I go, I got a 1 there.
That's one entire equation?
That's one entire equation. I just couldn't write it out. I can write it up here for you.
No, that's fine. That's fine.
Can you all see right here? Or is that reflection? I'm just thinking you can't see that. Can you see it? Are you okay with Dominic? I know that was Dominic.
Yeah, I'm cool.
And Dominic, how come you didn't say, when I told you, I actually put both your grades in Blackboard, but the second one didn't record. I don't know why. It didn't save. And then when you text me back, you know, when you don't text me back, I think you're being rude. You gotta say, okay, thank you. I hate you.
Your messages have gotten so short, it seems like you don't want to be bothered or something. I didn't want to, like, you know.
Oh, no, it's just I usually try to do my grades on Sunday. Now, you're not bothering me at all because a text, what I like about text is I can leave it there as long as I want before I respond to it. It's not like when the phone rings. You
Right.
can text me all day long. I think I texted Felix at like 3 in the morning or something. Or he texted me at like 3 in the morning. I can't remember. Anyway, I think we got this right. So let's go ahead and we'll work it out. I think that was Kevin that asked about if I distribute this to get rid of the parentheses. So I got a -1 times this will give me a negative IB. I got a negative times that negative is a positive IA. And so that's the first part of it. So this is really not a good way to do this. I'm gonna put it above. We'll put it up here. I hope you guys can see it. So right here, I'll do it again. I got a negative IB. I got a positive IA. I got a 4. I got a -2 IB. I got to do the same thing down here. I got to distribute. So I got a -3 IB, and then this gives me a positive 3 IC, and all that equals 0. So If I work it out, that's what I get. Now, you make sure I did it the right way, because like I said, I didn't work this out at all before. So I think that's the right equation. I'm going to erase this. And now we got to combine like terms, Kevin. I guess this is the part you were asking about. So I got IA there. So I'm just going to put it over here. So I got an IA there. So we'll put this down here, IA. I got a negative IB there. I got a -2 there. Add those together, I get a -3 IB. So I got a -3 IB. I got, oh wait, I didn't do that right. Look, I got a negative IB. I got 2 more there. That's -3. I got 3 more there. So actually, that's a -6 IB. -6 IB. And then I got 3 IC. I got this 4. I'm going to move that to the other side. That's going to change it to a -4. So what I'm getting right here is IA minus 6 IB plus 3 IC is equal to -4. Now, did anybody work it and get that?
Yes.
Okay. Kevin, does that help? I don't know if that answered your question or not. Did that?
Yeah.
Okay. All right. So we got one more to do, and it's 1:53. We got plenty of time. So go ahead and give me that last loop equation, and then I'll set the determinant up, but you guys are gonna have to solve it because I don't have enough room to solve it. But go ahead and give me the last loop equation. Make sure we agree on it, and then we'll solve it. I gotta get a bigger whiteboard. Okay, so let's I don't know what I did with my marker cap. I'm gonna lose the marker. Turn it. All right, well, oh, it's right here. All right, so let's go ahead and solve this now. Try to do it in green. See if that sticks out. So if I start right here, I got that resistor with 2 currents. So I'm gonna write it as a -3. This time, since I'm in the IC one, though, I'm gonna write IC minus IB. So that puts me right here. Right here, I go from a minus to a plus. So I write that as a plus. That's 2 volts, plus 2. And I go from a plus to a minus. That's a -4 IC. And all that's got to add up to 0. Now, this is the one where I have the window here, and it doesn't touch IA. So I got to put that placeholder in there. You got to remember to put that 0 on it. So once we do all the math, let's see. I'm going to go ahead and just let me change this to blue. So if I multiply this, I got -3 times this. So I got a minus 3 IC. I got a minus times a minus, which is a plus 3 IB. I got the plus 2, and I got minus 4 IC, and all that's got to equal 0. So that's all one equation. So if you add that up, I'm going to come back over here and write it down here. If you add that up, I don't have an IA in there, so I got to put that placeholder in there. So I'm going to write 0 IA. Now, zeros are actually nice because, you know, when you put that in the determinant, that whole row cancels out and you don't have to worry about it. So actually, the more zeros you have, the better. The easier it is to solve. So I got 0 IA, and then let's see, I got 3 IBs. So I got plus 3 IB. And then I got minus 3 IC, minus 4 IC. I got minus 7 IC. And if I bring this 2 to the other side, all this has to equal negative 2. So there are my equations, if you can see them in the camera. And we're going to solve that system using determinants. So I'm going to set the determinant up for D. You calculate it, and you guys can just verify with each other to make sure you got the right answer. So I'm going to get rid of this.
So,
Yep.
so I got a question.
Okay.
I think you make some mistake for the first equation.
For the first equation,
Yep.
this one.
Yep.
Okay. Well, let's see. Let's go back and let me check it. So for that first equation, let me redo it, and we'll see if I get the same thing again. So what I got for the first equation was right here, we had a 2, and then we got a minus IA, then we got a minus 4, and then right here we got a minus. I'm in the IA window, so it's minus IA minus IB, and all that's got to equal 0. So that looks like the equation for the first one. And then if I work it out, let's see, I got a minus IA here and a minus IA there. That's minus 2IA. I got minus times a minus is a plus IB. And then right here, I got a 2 and a negative 4. That gives me a negative 2. But when I move it to the other side, it gives me a positive 2. So I should have a negative IA, negative 2IA, plus IB, plus IB. We had the placeholder for 0 and move. So I'm getting the same thing. What did you get?
Yeah, it's right. It's me. I make some error. I make a minus negative 4
Okay.
times
All right.
IA minus IB.
Okay. So you guys have your calculator, you know, when you're doing this. So we're doing this freehand on the board, so we'll make mistakes. But when you're doing this for the test, you'll have your calculator and time, so you won't make those mistakes. But you can always check it. It's always good to check it. Nothing wrong with checking it. Now let's set up the determinant to solve for D. And I'm going to try to use, I guess I'll keep using the purple and see if that works for you guys. So I got a negative 2. I got a 1, 0. I got a 1, negative 6, 3, 0, 3, negative 7. And then we'll repeat this, negative 2, 1, 0, 1, negative 6, 3. Now you guys are going to have to calculate that for me. And I didn't work this out, but I had let me see if I got my notes. I had a student work this out last semester. I think he got it right, so I didn't work it out by hand. Usually I worked the problem before. And let me see if his equations match ours. Yep, they do. So I think I have the answers here, but I want you to work it.
I got D as 56,
You got negative 56.
positive 56.
D equals positive 56.
Oh, wait, never mind. That's wrong.
Okay. Anybody get a D yet?
Negative
Minus
1.
59.
Negative 59. And let me look at the sheet. So my student guy, this guy was an A student, so you know it wasn't me. I wasn't an A student. He got negative 59 for D. So we'll assume that that's right. I'm gonna put that in the corner right here. Now, if you didn't get negative 59, go ahead and rework it. We got time. It's just 202. So go ahead and work it. Make sure you get that so you can see how this is done. If you did get it, go ahead and set it up. Set up the system to solve for A. Hopefully you got this down. I'm going to erase this in just a second. I don't know if you're still copying it.
Sir, we can use substitution for do that.
Well, okay. On the test, if I say solve this using any method, you can use any method. But if I specify solve it using superposition, you got to use that. If I say use mesh, you got to use that. And then next time, when do we meet again? On Friday? On Friday, I'm going to show you a third way to do it. You'll have 3 options. But if I tell you to use a specific method, I want to see that you can use it. Now, one thing that's good to do, though, since you brought it up, like, let's say we didn't know the answer to this. I got an answer sheet from a student from last year, but what you can do is solve it using mesh and then solve it using superposition. That's what I asked you to do with that problem from the last video. I gave you a problem at the end, and I wanted you to solve it using mesh and superposition to see if you got the same answer. You know if you're doing it right. And if you got it wrong, then you don't know which one is wrong, but at least you know it's wrong, and you have to kind of just work it out. So I'll put that other video up in case you missed it. I'll do that after I'm done here, and we'll see. Does anybody know if Felix got in or not? We don't know if he got in.
Yeah, he's in. He wants you to run a series parallel, like from the worksheet near the end of the video, so that way it's recorded and he can go back over it.
Okay. I don't have my worksheet here, so maybe when we're in, if you guys have a worksheet, you can give me a problem off the worksheet, and then we'll work it. I'll work it for him. We don't have to stay at that point. I'll disconnect the session, but if you want to watch it, you can. Let's go ahead and, what are we looking for? A? Let's set it up for A. For A, so I got to put the 2, the -4, and the -2. So I'm taking my answer column and putting it over here in place of the coefficients for A. And this is what I got. And then the rest is just a 1, a -6, and a 3. 1, -6, and 3. And 0, 3, -7. 0, 3, -7. And then I repeat the first 2 columns. So I go 2, -4, -2, 1, -6, 3, and divide that by D. So you got to work it out, and let me know when you got an answer, and I'll let you know how it compares with the answer I have here. Let me know when somebody has an answer.
Negative 0.54.
So somebody said IA is negative 0.54 amps. And if I check my answer sheet, he has IA negative 0.54. So whoever that was, you got it right. If you didn't get it, this is the right answer. Go ahead and keep working and see if we get that number. Now, what's the significance of the negative sign? What does that mean?
It's traveling in the other direction.
Right. So on your diagram, what you got to do is flip this loop current. Instead of going clockwise, you're going to turn that around, make it go anti-clockwise. And then I'm going to put the actual value in there just so I know. Now I'm going to convert that to milliamps. It just feels better if it was in milliamps to me. And I don't know if you can see this red or not, but hopefully you can. This is 540 milliamps. It's going counterclockwise. Okay, so I'm going to erase this in just a second. So if you don't have it down, write it down, and you'll have the video to go back and look at this stuff. And then we'll see what you get for IB. All right, so for IB, I got a -2, a 1, and a 0. I got a 2, a -4, -2. And I got a 0, 3, and -7. And then I repeat, -2, 1, 0, 2, -4, -2. I got to divide that by D. So let me know when you get a answer for this one. And then we'll check it.
Negative 0.91.
Negative 0.91. Is that what you said?
Yes.
All right, let me see what he got. This is IB. He got a positive 0.92. So double check this, make sure it's negative. He could be wrong though, but I'm wondering if anybody else got a positive.
I got a positive 0.98.
Okay. Anybody else? Let me just make sure this is right. 2. That's right. That's right. Okay, so that looks good. All that looks good. So he's agreeing with this answer. It was off by a sign. So I'm wondering, anybody else get anything like this but positive? I got it's 211. I'm trying to avoid working it out by hand, but I might have to. You guys try to rework it and see. Make sure
I got the same answer, negative 0.91.
You got a negative 0.91? Okay. Well, I'm going to assume this sheet is wrong because you got a positive 0.92. So the 0.9 I'm not worried about, but the negative sign I am. So we're saying that we got this as a negative. So if that's correct, then I got to reverse the arrow. Oops. I got to reverse the arrow. And then I can write it as 910 milliamps. All right. Okay, we got one more, and we got, what? About 5, that's about 8 minutes or something like that. So let's see if we can get IC real quick. And then we'll call it a day. So I get -2, a 1, and a 0. I got a 1, -6, and a 3. I got a 0. I got a 2, -4, and a -2. And I'm going to repeat. And this is going to be for IC. I got to divide all of this by D. Let me know when you got a value for IC. Anybody got a value for IC?
0.067 or 68.
All right, let me see what he got. Okay, is it 0.068 or is it 0.68? Because he got 0.68.
I thought it was 0.068.
I got 0.68.
You got 0.68? Yeah. So I'm going to go with the 0.68 only because. So I think we're good on this 0.68. The only thing. So what you would do now. Let me put that here. I guess I'll write it as. All right, so at this point, what you would do, you would write the current for each individual resistor. This resistor has 540 milliamps. Now, how would I get this one? Well, I'm showing 540 milliamps coming up and 910 going down. So I would subtract the two to get the value in here. And it would be in the direction of the larger current, which is the 910. And then the same here. I have current going up of 910, current going up of 680. So I would add those two in that case. Now, the only thing that didn't agree with the answer sheet I got was this one. He claims on the sheet that this should be negative. So we flip that around. So you guys will go back and rework this. Just double check this number, the sign of this number, to make sure that we got it right. But the technique is right. You can see that our math might be off by a negative sign. I don't know. Of course, if that's off, it's going to throw everything else off. So we'll go back and check that. Sorry I don't have it worked out, but I think you can see the technique on how to do this. So check that answer, make sure we got it right. And then the only thing I could ask you to do is to give me power. But like I said the other day, if you know the current through the resistor and the value of the resistor, you can give me whatever I want. Voltage, power. All you really need to know is current and the direction of current. So that's mesh analysis. Anybody have any questions for me before we end this?
Ron, how do you?
Go ahead.
Ron, how do you want us to submit homework? I mean, you had a quiz a take-home quiz.
Yeah.
How did you want us to submit that?
Yeah. That's a good question. I think that's Steve. I'm going to have to, what I don't want is to go through a bunch of emails. It's easier to set it up in Blackboard and have you submit it like you submit the lab, the multi-sim lab. But the problem is some of that homework that you got, some of that I already have in the grade book. Some people already turned part of it in the grade book. And so when I set the grade book up, I got to do something special to have it accept those PDF files. So right now, I don't know. It's just going to, I may have you just take a picture of it and send me, scan it and send me, but it's just going to be hard for me to keep track of all these emails. Do you know exactly, Steve, what you have outstanding? What don't you have that's turned in? What do you have that's not turned in?
I think the only thing I have left is the quiz that you gave us to take home.
I think that take-home quiz, and you guys, by the way, on that quiz, you want to make sure you talk to other people. I know you guys can't visit each other, but that quiz can be, I probably should put a solution sheet up for that. But I don't know if I want to do that, though, because I reuse that quiz. But before you hand it in, check with other people to make sure your answers agree. But I think, Steve, what I'll have you do is just, since nobody's turned that in yet, I don't think nobody's turned, I can just have you submit that by PDF. I'll put a link up on Blackboard, and I'll do that after this is done, and you can submit that. If you're ready to turn it in, you can turn it in, but I highly recommend, I don't know if you guys do something on Facebook or if you can share files, but that you talk to each other, make sure that, you know, you got the same answers and that you can work it out. I'll put a link on Blackboard. You can submit that as a PDF with that app that you use, the same one you use to submit the multi-sim lab. And then anything else that you guys have outstanding, I guess I have to do the PDF thing as much as I hate it, but you'll have to email it to me. But if you email me anything, please make sure you text me so I'll know to look for your email, because I get 100 emails a day between all the students and all the other stuff. It's just so easy for me to lose an email. So I'll have a link to submit the quiz, and then anything that you got a 0 on because you still have it, you haven't turned it in. Like some of you still haven't turned in the energy project. You got a 0 for it, so you want to get that turned in. That should be a free 100 points or a free grade. But I'll have to have you take a picture of that and send it to me by email, okay? But the quiz, you'll submit that. I'll put a link on Blackboard here within the next hour. You can submit it. Does anybody have one of the homework sheets with a series parallel problem on it? Because I don't have the book here, and I want to. Yes. So Somebody must have their mic open or something. Can you guys hear that feedback? Or am I the only one that heard it? I'm going to erase this.
I've got all the homework stuff here, but I want to you want me to read it off to you.
Okay, let me get this clean. And we'll work one of those problems, and then I'm going to keep recording this just in case somebody wants to see this. Okay, so you can read the problem. Well, I'm getting some feedback. I don't know why. Let me turn this down. It's been doing well all day long. Okay, you can read it.
Let me know which sheet we're looking at. Which one
You
is
wanted
it?
to do a series parallel. Any series parallel, I guess, will work. Don't give me one too hard now. I don't want to be down here all day, but give me one that you can see, you know. So see if you can find a series parallel. It could be one of the homeworks. I don't care. It could be, I don't know if you wanted to see a series parallel with an unknown or.
I don't know what sheet he was talking about. Matt, are you still in the chat? Are you still reading?
He should be.
His problem was he couldn't hear anything. So if you want to talk to him, you have to type in the chat.
Oh, can you type him a message and see what kind of problem did he want to see?
Matt's not here. He left already.
Oh, he left. Okay. Wow.
Just make one up and show him so that he can watch the recording later.
Yeah. All right. Let me see if I got one handy in my notebook. I'll do that, and I'll just record it. Yeah, I'll do that. Let me get my book, and then I'll record it, and then he can watch it. I'll be back. So you guys, I'm going to go ahead and do that. If you want to disconnect, you can. If you want to see me do it, you can. I'll see what I can find, and then I'll put it on the board. I'll be right back. I guess I should learn to use the edit feature in YouTube to edit out these dead spaces. I know this video is going to look really funny. Plus, I make the videos public, so anybody can really watch them. There's going to be a lot of dead space in there. All right, let's see what I got here. This may be one that we worked. I just got a sheet out of my notebook. So I'm going to just work that one. I don't know if he worked it or not. And I do not have my glasses, so Let's see if I can, oops. See if I can read this. All right, so I have 3 volts. Okay, I feel like we worked this problem before, but I'm not sure because I've done so much of this in the last couple of weeks. So this might be something you already worked, but that's okay. So the way you would handle something like this is a basic series parallel problem where you know all the values. There's 2 types. There's one I'll give you where you know all the values, and then there's the one where I might erase a resistor or you might not know the voltage. That's a series parallel with random unknown. So we'll start, you got to be able to do this before you do the other kind. So what I would do is any volts, you want to shade those in. So anything that's in parallel with something is going to have a node above it and below it. So these 2 resistors are in parallel, so I'm going to shade the nodes in that defines the parallel connection. So I got this one, and I got this one. So I shade the nodes in, and then I'm going to name them. I call one A and one node B. Now you'll notice the battery is over here. I went to the other side of the circuit, and I started to do my work. My house is on this side. You want to do that. Whatever side the battery is on, you want to start on the opposite side. The battery is over here. I started over here. The battery had been here. I would have started over there. If it was in the middle, then I would flip a coin. It doesn't matter in that case. But here, it's on the left. Most of the time, it'll be on the left. I'm going to start on the right. And either I'll have resistors in series or parallel, and what I'm going to do is combine them. What I want to end up with is a circuit. So I'm going to draw the series circuit. It's called an equivalent circuit. I want that equivalent series circuit to the original circuit. So if I start over here, I see that these 2 are in parallel. If I combine those, I'll have this resistor, and the equivalent resistance of those 2 combined. So I'm going to draw the series circuit that is the equivalent circuit of this one. Okay, so I have my 30 volts. R1 stays the same. It's 120. These 2, I'm going to combine those into one resistor. That's going to be R2 in parallel with R3. It's equivalent resistance. And R4 stays the same. That's 390. Okay, so I got to get the equivalent resistance here. I got R2 in parallel with R3. What I do when I have two resistors, you can use whatever you want. I guess in this case, product over sum rule would work. So to do this, to find the total resistance in parallel using the product over sum, it will be R2 times R3 over R2 plus R3. Do that to get this number. So we'll put the numbers in, and then we'll get a final circuit. So I have 1.8 times 2.2 over 1.8 plus 2.2. Notice that these are in K, so I just left them in K, and my answer will be in K. So I look like some people still out there. If you got your calculator, I don't have anything to calculate with. I don't know what I did with my calculator. I lost it. But I need the product. I need 1.8 times 2.2 divided by the quantity. That looks like a 3 or something, I think, when you add it up. 4. What do you get for this?
99.
0.99?
Yeah. If I divide by 4.
Well, 1.8 times 2.2. Oh, you mean right here? You divided that by 4?
Yeah.
Really?
Yeah, 1.8 times 2.2 is 3.96.
So you get 0.99?
Yeah.
Okay. There's nothing wrong with that answer. Just kind of, I don't know why I expected something different. Well, I'm going to erase this. So hopefully, Felix, when you look at the video, you can see what we did here. He said that was Kevin talking. When he did this, he got 990 ohms.
Why are you dividing by 4 though? Is that a plus? That's a plus at the bottom?
Right.
Yeah. Okay. Yeah. I'm sorry.
Okay, so we got, if I write this in 0.99 K ohms. So I'm showing that right here. Okay, so I'm going to erase this. I told him I would go slowly through this so he can see exactly what we're doing. So I'm moving really slow. Now, what we got to do, once you get down to the series circuit, what you want to do, any node information, write that in the series circuit. So in this circuit, since node A is right here, it's going to be right here in this circuit. I know that because it's at the top of these two parallel resistors. And in this circuit, that's this. So this has to be A, and this has to be B. That's important because what we're going to do next is we're going to find voltage drop across each of these resistors. And when you get this voltage drop, AB, what you found is a no voltage, and that's always going to be across more than one resistor. In this case, it's going to be across both R2 and R3. We'll get to that in a second. So what we got to do here is find the current. So I got to find the current. So that's pretty easy. Ohm's law. I equals V over RT. So I got 30 volts over, I got 390, I got 990, and I got 120. Can somebody add that up for me? $120, 990, and 390.
$1,500.
It's 1,500. I'm going to write that as 1.5 K. Just so we keep this in milliamps. 1.5 K ohms. Okay, so what happens if you take 30 divided by 1.5 K ohms? 30 divided by 1.5, and my answer is going to be in milliamps because I got K on the bottom. 30 divided by 1.5. What is that?
20 milliamps.
How much?
20.
20 milliamps. So what I'm going to do is you want to use your coloring pencils and pens. I'm going to show that 20 milliamps in series right here coming out of the battery. Right away, what you want to do is show that coming out of the battery over here. Because what you've done here with that 20 milliamps, you've actually solved the current here, but whatever current is here is also here. This is the current leaving the battery. To get back to that battery, you got to go through R4. So if you know the current here, then just by the circuit symmetry, you also know the current in this resistor is 20 milliamps. So basically what we're doing here is this series circuit is helping us solve the big circuit. All right, well now let's get the voltage drops. Now, to get the voltage drops, this is in milliamps, so I'm going to have this in K. If you don't remember, if I take milli times K, they cancel out. So I can just, on my calculator, instead of writing 0.02 times 120, I can write 20 milliamps times 0.12 K ohm. And this will cancel. On my calculator, I can just do 20 times 0.12. So I'm going to do that for each resistor here and get the voltage drop. So I'm going to use a different color for that. So give me 20 milliamps times 0.12 K is what?
2.4.
0.4 volts. I'll put a circle around that and show the leads going from the left and the right of the resistor. And right away, I'm going to put that 2.4 over here because this is helping me solve the big circuit. And every time I get information over here, it's like putting together a puzzle. It should become clearer and clearer every time I get a value over there. Okay, now I got 20 times 0.99. How much is that?
19.8.
19.8. Now that 19.8 volts, this is important. Actually, it's a node voltage. Anytime you get a voltage across an A and a B, that's a node voltage. It extends from A all the way down to node B. You got to show that in the original diagram. I got 19.8 volts going from this node to that node. And the reason I'm stressing that means that both R2 and R3 get that 19.8 volts because they're in parallel. And then we'll do the same here. I got 20 times 0.39. How much is that?
7.8.
7. Now we could have took the 30 minus 2.4 minus 9. We could have got it that way, but we'll just keep doing what we're doing. I got 7.8 volts. I'm going to show 7.8 volts going from here to here. Now, in the series circuit, once you get the current and all the voltage drops, then we come over here and we say, all right, what am I missing? Well, I got every value except for the current in R2 and the current in R3. But notice I know the voltage across both resistors and I know the value of each resistor. So it's just a calculation using Ohm's law. So I'm going to show this current. I'm using red for current. So I'm going to stick with my colors. This current is going to be 19.8 volts divided by 1.8 K. I'm going to leave this in K ohm, understanding that if I have K on the bottom, my answer is going to be in milliamps. So somebody take 19.8 divided by 1.8. Let me know what you got. Everybody get it? 19.8 divided by 1.8.
$11.
Okay. Like 11 milliamps. All right, now I could do the same thing here. I can say 19.8 volts divided by 2.2K and get the current, but I see that I got 20 milliamps going into node A, 11 leaving, so I don't even have to do the division. I can keep it easy. This has to be 20 minus 11. This has to be 9 milliamps. So I checked now. I got the current in each resistor. I got the volts across each resistor. As far as I'm concerned, the circuit is solved. All I can ask for, Felix or whoever else is looking at this, would be power. And power is always V times I. For this one, V times I. For this one is V times I. If I want the total power, that's easy too. It's V times that I. It gives me total power. So that's how you solve a series parallel. Now, the only thing I can give you, I'm not showing you here, I can give you the same thing, a series parallel with unknown values, then you would approach it a little differently. What you would do is go out here and on a circuit like that, they'd have to give you, say, the value of this resistor and the voltage. They have to give you two pieces of information, some of the circuit. You either have to give it to you or you have to be able to get it from the circuit. And then it's kind of the same thing. But Felix, I'll let you work this. Hopefully that helps you out. And then if you need to see some of the other stuff with random unknowns, let me know, and then we can make another video. Maybe by then, the phone issue that you were having will be resolved, and we can do a video thing, and I can show you. But guys, thanks for your help calculating this stuff for me. And does anyone else have any questions before I exit this session? Everybody all right? Okay, well, thank you again for calculating. You guys have a great rest of the day. I'm going to put this up on YouTube. It'll be available, and it was something else I told you I would do. I'll put a link up for the quiz, the take-home quiz I gave you with the shorts in it. Short circuits in it. I'll put the link up for that too here in just a second. So you guys have a great rest of the day, and I will see you. I'll send the link out. I forgot the lab. The lab, I'll tell you what to do for lab. It'll be something you do in multi-channel, and you'll submit it that way. Have a great rest of the day, and I'll see you later.